Hi, PLMS. Today we're going to be using the discriminant. I can use the discriminant to describe the solutions. What on earth is the discriminant? Well, that's my job to teach you. Here is the discriminant, and you may notice a connection between the discriminant and the quadratic formula. The expression under the radical in the quadratic formula is the discriminant. So we've already learned the discriminant or the quadratic formula, negative b plus or minus the square root of b squared minus 4ac. So I'm just going to extend my radical sign here all over to a. Well, the discriminant is simply b squared minus 4ac. So we're going to be able to use that expression to make some determinations about how many solutions a polynomial has. So here's the properties of the discriminant. This is also located in your textbook. I just copied it for you on your notes as a convenience. For the equation ax squared plus bx plus c is equal to 0, where a is not equal to 0, you can use the value of the discriminant to determine the number of solutions. When we solve the problem and the answer is greater than 0, that tells us that there are 2 solutions. When we solve the expression and it is equal to, the equation and it's equal to 0, that means there's 1 solution, because what that tells us is that the graph would hit the x-axis at exactly 1 point. Just like where there are 2 solutions, it would hit the x-axis at 2 points. And then it is possible that there is no solution, either because it's negative and it's under the x-axis, or because the equation is positive and it's above the x-axis. We'll talk about what that's going to look like here in just a minute. So let's go ahead and look at our first example. And the first thing we want to check out is this equation in the form ax squared plus bx plus c is equal to something. So we can see that it is. So ax squared plus bx plus c equals to 0. If not, we might have to do some adjustments or moving around to make the equation like that. This one is nice and easy on us. So I'm going to, first step, I'm just going to pull out the value of a, which would be 1, because that 1 is in front of the x squared. The value of b is 3, and the value of c is 7. The discriminant is b squared minus 4ac. So we're going to substitute in b, we know, is 3 squared minus 4. A is 1 and c is 7. And then we just simplify. Order of operations tells us to do the exponent first. So 9 minus, and then I've got 4 times 1, which gives me a negative 4, times 7, which is 28. So we have 9 minus 28, or negative 19. From here, we have to make a comparison. So negative 19, as far as the rules that we just saw, we were trying to look to see if we are greater than 0, equal to 0, or less than 0. So right here, you might want to write yourself a note, compare to 0. So we know that negative 19 is less than 0, and according to our guidelines, if it is less than 0, then that tells us that there is no solution. So we're just comparing to 0. So what that means is, if I was, let's say that we were graphing, then I could have a parabola that is maybe going up or is going down, but that it's never going to cross the x-axis. In this case, I know that it has to be above the x, because this was positive. The x squared term was positive, so we know that the parabola is going to be going up. You don't have to know all that, but I'm just telling you what you're looking for. And if it was the graph, the solution is always the place the graph crosses the x-axis. our next example. So the first one, we liked it. It was in the format ax squared plus bx plus c. This one, not so much. I've got the 1 or my c on the other side of the equation. To move it to the other side, all we're going to have to do is subtract 1, and whatever I do on the right, I'm going to do on the left. So because we want it to be equal to 0, so that's because that's our comparison. We're comparing our equations to 0 each time. So we have 3x squared minus 5x minus 1 is equal to 0. From here, I want to pull out my a term, my b term, and my c term. And who remembers what the discriminant expression is? I bet you do. B squared minus 4ac. So we're going to go ahead and substitute into the discriminant. We've got b is equal to -5. So that tells us all of b is squared. That's what the discriminant tells us to do. So I'm just going to put -5 in parentheses and square it, minus 4 times a, which is 3, times c, which is -1. -5 squared is 25. And then on this side, I've got -4 times 3, that's -12. And then -12 times -1 gives me a positive 12. 25 plus 32 gives me 37. Now from here, remember, we're comparing to 0. So I know that 37 is greater than 0. And according to our guidelines, if our discriminant is greater than 0, then how many solutions do we have? You might want to look back at that. The answer is 2 solutions. So what does that tell us? That there are 2 solutions. And I want to go back and emphasize the directions, because these directions said find the number of solutions of the equation. It doesn't tell us to find the solutions. It just tells us at this point we're just finding the number of solutions. So a couple of things. This is positive. So what that means in terms of what we're looking at, then the graph of this equation would be sitting on the would cross the x-axis at 2 different points. That's what we know right now. It's going to cross 2 times, and it's a positive, so it's going to be going upward. It's not exactly in that place. I just wanted to illustrate that it's at 2 different points on the x-axis. All right, our last example where we're just finding the number of solutions, the first thing we want to look at is the format of our equation, and it is in the format ax squared plus bx plus c. So from there, I want you to go ahead and pause the video, and I want you to do this one on your own and determine the number of solutions. Once you are finished, then start it back up and check your work. So this particular equation is going to have 1 solution because it was equal to 0. So 0 is equal to 0 tells me that I'm going to have 1 solution. Once again, it's positive. Now this one, I can tell you exactly where that's going to sit, because if you're finding the vertex, it's -b over 2a. So you would find that this graph would have shifted 2 positions to the right, and it would be sitting on the x-axis. That's what it means when it says that it's just 1 solution. It means that it's sitting on the x-axis. So that's going to tell us, that's how we use a discriminant. On the next set of problems, it says find the value of the discriminant and the solutions of each equation. So if you have 1 solution or 2 solutions, then we're going to have to find that either by factoring or by mathematically working it out. And unfortunately, a lot of times with these equations, it means that you're going to have to go into using the quadratic formula in order to solve. So if there is no solution, we don't have to do anything else. But if there is, then we're going to have to find the solution. So for this one, I'm going to pull out my A, 1, B is -2. It's in our right format. We know that. And we end up with I'm going to write the discriminant each time so I can substitute in. So I've got -2, that quantity squared, and then A is 1, C is 5. That's going to give us what? 4 minus 20 or negative 16. Our comparison is always against 0. Negative 16 is less than 0, so we have no solution. That tells us that the graph would not cross the x-axis. It would be sitting on top of the x-axis, but not touching the x-axis. It would be above the x-axis is what I should be saying. All right, we got one more here. So as far as our format, it's looking good. And so we're going to use the discriminant to tell us how many solutions, if any. That's the advantage of using the discriminant, is that if there are no solutions and we don't go through all of that process for the quadratic formula, when I can just use a discriminant and easier find out a little bit more easily how many solutions there are. So as far as our A, we've got 4. B, I've got 1, C, negative 5. So we've got B squared minus 4AC. So 1 squared minus 4 times negative 5, 1. And then I've got negative 4 times 4, which is negative 16. So it's a negative 16, and it's a negative 5. So that's going to give me a positive 80 and 81. So right away, 81 is greater than 0. So that tells me that we're going to have 2 solutions to this problem. So I guess we must use the quadratic formula. Unless you can figure out a way to factor it and solve, you're going to use the quadratic formula, and we're going to substitute in. Your substitution should look like this. You can go ahead and pause the video and do this part on your own, and then just start it up when you have figured out your solution. All right, so we ended up with our solution being 1, or it would be what? Negative 1 2/8 or negative 1 1/4 simplified for your solution. So that tells us that the graph would cross the x-axis at positive 1 and at negative 1 1/4. All right. I hope you enjoyed your lesson on using the discriminant.